Hi, calculus students. These notes are a continuation of our notes from class on limits at infinity. And specifically in these notes, we're going to be looking at examples with rational functions. And the idea here is we only really need to look at the ratio of the leading terms in a rational function. Okay, so we only need to look at the ratio of the leading terms. Because as the idea is as x goes to infinity, x to the third looks a lot like x to the third plus 2. So we're kind of going to be looking at things of the form like some coefficient times x to some power divided by some other coefficient times x to some other power. We're going to kind of be using this form. I'm going to be talking about the exponents n and m, so kind of keep that in mind. Our first example here is going to be the limit as x goes to infinity of 3x to the fourth minus 7x plus 9 divided by 7x to the fourth minus 4. And again, like, if I'm thinking about this graphically, the idea is that this thing graphically as x goes to infinity will look very much like if I just kind of zero in on the leading terms of top and bottom and just think about these, then it's going to look graphically a lot the same as if I have those other terms. Because as x goes to infinity, it all kind of evens out and looks the same. So that actually makes this process a lot easier, because if I only care about these terms, then I can just think about the limit as x goes to infinity of 3x to the fourth over 7x to the fourth. And now notice, this is a situation where my two powers are the same. They both have to the fourth power. So I'm actually going to, underneath the example, I'm going to write this is a situation where n and m, the two exponents, are equal to each other. So n equals m. So what happens here, you might already be thinking, oh, can I cancel out the 2x to the fourths? And the answer is yes. So we know that this will simplify to just be 3/7. So I can think, what's the limit as x goes to infinity of 3/7? Well, 3/7 is just a constant, so it's just going to be like a horizontal line. So the limit of that horizontal line is exactly that same value. So whenever n equals m, you just take the ratio of the coefficients, and that's your limit, or your answer. That means that there's an asymptote, right? There's a horizontal asymptote at 3/7 as x goes to infinity. Okay, let's look at the next example. It's going to be the limit, we'll do as x goes to infinity of, I'm using similar numbers, but I'm changing the problem slightly. So I'm going to say 3x to the third minus 7x plus 9 divided by 7x to the fourth minus 4. Okay, so what's going on here? Well, first of all, if you look at the two exponents, the exponent in the denominator is greater than the exponent in the numerator. So that's like, or the numerator is less than the denominator. So I'm just kind of denoting that to kind of keep that in mind. So we're going to start the same way, which is let's just zero in on the leading two terms. So then I'm thinking, now what's the limit as x goes to infinity of 3x to the third divided by 7x to the fourth? Well, just like I could simplify here with my x's, I can also do the same thing here, except they don't have the same number of x's on top and bottom. So I'm going to be left with one x on the, like, all of these will cancel, and I'll be left with just one x in my denominator. So this will become the limit as x goes to infinity of 3 over 7x. And what happens here, well, this kind of goes back to the types of problems we were looking at in class, where if I have a number divided by some quantity going towards infinity, I have x in the denominator, then this is just going to be 0. So anytime you can simplify, you have a number on top and your variable on the bottom, you know that that's going to end up going towards 0 as x goes to infinity. my next example. So now we're going to kind of look at the reverse, where the exponent in the numerator is bigger than the exponent in the denominator. And why not? We'll do a negative infinity example. So if I have something like 3x to the 8th minus 7x plus 9 divided by 7x to the 3rd minus 4. So the idea, once again, I'm always going to start by zooming in on the leading terms. So I'm thinking, what's the limit as x goes to negative infinity of 3x to the 8th over 7x to the 3rd? From there, I'm going to simplify. So I'm thinking, okay, I can cancel out all of these, and that means there's 5 left on top. So this is equal to the limit as x goes to negative infinity of 3x to the 5th. Oh, there's a 7 too. So over 7. So, well, what is the limit of this as x goes to infinity? Well, don't get thrown by the 7 on the denominator. That's just a number, so it's just like we have a coefficient of 3/7. This is a polynomial where, so I want to think about my end behavior here. So I know it's odd and the leading coefficient is positive, so it should look something like that, which means as x goes to negative infinity on the left-hand side, my graph is pointing down, so my answer should be negative infinity. So anytime n is greater than m, you're going to end up canceling all your variables on the bottom. You'll be left with some polynomial, and I'd refer you back to the end behavior chart from the first part of the notes. Okay, this is going to be our last example. We have the limit as x goes to infinity of, this one is a little interesting, so I'm going to add a square root, because why not? The square root of x squared plus 2x plus 1 divided by x squared plus 1. I'm going to start the same way, where I zoom in on my leading terms. So this is the square root of x squared divided by x squared. And now I'm looking to simplify. Well, I can actually, I couldn't have simplified when I had all 3 terms inside my root, but now that I'm just looking at 1 term inside my root, I know the square root of x squared is just x. So now I have the limit as x goes to infinity of x over x squared, and now I can keep simplifying, right? So there's another x that can be canceled out on top and bottom. Now I have the limit as x goes to infinity. Well, there's no more x's on top, so I'll put that like a 1 on top. On the bottom I have x, and from class, from the first part of the notes, we know that the limit as x goes to infinity of 1 over x is 0. So I'm just going to give you all a couple of u-try problems, and these should go pretty quick. I think all limits to infinity, it's like once you kind of see what you're doing, it doesn't take you too long to do it. So the first one is going to be the limit as x goes to negative infinity of 3x to the 7th minus 7x plus 9 divided by 7x minus 4. The second one is the limit as x goes to infinity of x squared plus 2x divided by x to the 3rd minus 3x plus 1. And the last one will be the limit as x goes to negative infinity of 3x to the 6th divided by 2x to the 6th. So try those out, and we'll be practicing this next time we have class.